Get your work done today. All right, ladies and gentlemen, it is the 31st of January. Yay, January's over. All right. On Monday, February 3rd, will be a review day. So today is the last day of notes. You need to use your notes because I will not be here. So you're going to get a review worksheet for your test, and you'll use your notes to answer the questions, and you will be able to use the review on the test, which means you need to write on that review lots of things. Don't just write a number answer because that doesn't tell you how to do it, right? Write out the steps so that on the test you know what steps to take, okay? Or maybe you want to use your calculator to get an answer. Make sure you know how to use your calculator to get the answer because some of them you can literally just plug into your calculator and get an answer if you know how to use your calculator. So write the stuff on your test. There will be a key, but it's just answers. It's not how to do it. So you need to know how to do the stuff. On the 4th, on Tuesday, is your test on this material. Okay? So again, you'll be able to use your review and a calculator on the test. So please hold on to that review and write on it. Don't just write answers because answers are not helpful. Okay? So work together on that review on Monday. Figure out from your notes how to do stuff. Do as much as you can and write down as much as you can. Okay, today we're talking about inverse functions, and we're doing this really quick and dirty because I just want to give you an idea of inverse functions. We do inverse functions all the time when we do an inverse operation to solve. So inverses are really just figuring things out the other way, doing things in reverse. So to start, we want to determine if the function has an inverse and then find the inverse function. So again, write down your instructions. Determine if the function has an inverse, then find the inverse function. Which I'll talk about in just a second. Okay, so you have a graph here. So in order to have an inverse, a function, and this is a function, must pass what's called the horizontal line test. Now we've talked about the vertical line test, but this is the horizontal line test to have an inverse. All right, so this is the rule. A function must pass the horizontal line test to have an inverse. Well, the horizontal line test is very much like the vertical line test, except it's a horizontal line. So if I draw a horizontal line, you see that it crosses my graph in 2 places. That's not allowed. That's a big no-no. If it crosses 1 time, that's fine. More than once is not okay. So this actually fails the horizontal line test. And what that means is there is no inverse that we can do, okay? So since it fails the horizontal line test, we do not have an inverse that we can find, okay? So this is the real quick and dirty instruction here. So failed because it hit it 2 times. You can see if I draw another horizontal line, there it crosses again 2 times, and that's a no-no. All right, so looking at the second graph, this is a different looking graph, isn't it? Does this function pass the horizontal line test? Does it pass or fail the horizontal line test? It passes, yeah. If I draw a horizontal line, then it hits 1 time. That's okay. If I draw a horizontal line, it hits 1 time, and that's okay. So this one passes the horizontal line test. Now, to find the inverse, all we have to do is swap the x and y values. That's it. It's very, very easy. So what does that mean? Well, we're going to start here with this point. And I want to know, what is that ordered pair? What is that ordered pair right there? Almost. -1, 0. Very good. That's on the original function f. And I want to get the inverse. All we have to do is trade places. So -1, 0 is just going to trade the x and y. Trade places, what do you get? 0, -1. That's the swap. All right, all it does is trade places. So I'm going to plot that, 0, -1. 0, -1 is right here. There's our inverse point. So inverse just means swapped. What's this ordered pair right here? 0, 1. And if I swap it, what do we get? 1, 0. Swapped. So 1, 0 on my graph is 1 to the right, up none. So right there. And the last point right here is what? 2, 2. And if I swap that, what do you get? 2, 2. It stays the same. Very good. That one happened to stay right where it is. And so I'm going to go ahead and just connect those in a nice smooth curve like I was given. And this is what we would denote as f to the -1. And that's read f inverse. So that's more function notation. F to the -1 is our function inverse notation. And that's what that little -1 means, inverse. So this was our original function f, and then we have our f inverse, which we just connect in a nice smooth curve. Okay. Inverse functions happen to be reflections along the line y equals x. And so you can imagine if this line was a mirror, you can see how it's just sort of the mirror reflection of itself. Okay, and so it's kind of interesting. And so this is what we're doing to find inverses today graphically. A function that passes the horizontal line test is called a 1-to-1 function. And that's a special name, and that 1-to-1 function just means that it's a function that passes the horizontal line test. So another name for it is 1-to-1. Okay. A 1-to-1 function is a function that means that always has an inverse. So we can find the inverse of any 1-to-1 function. All right, so swapping x and y, easy to do. Any questions on that? All right, so example 2. Find the inverse. Again, we have this special notation, f inverse of x. That's how we would read that, f inverse of x. Negative 1 just means inverse, f inverse of x, of the one-to-one function. So what does one-to-one function really mean? It passed the horizontal line test already. So it's confirmed that it's passing the horizontal line test. So this is an equation, and that equation happens to already pass the horizontal line test. So that means that we're allowed to find the inverse. We can do it algebraically, and it's kind of the same way. So first of all, f of x is just like fancy for y. So f of x really is the same thing as a y value. And just like with the ordered pairs, we're going to go ahead and swap the x and y. They're going to trade places, and that's the first thing we want to do when we're solving for an inverse function. So right now it says y equals, what should we trade it for? X. They're going to trade places. So I have x equals negative 2/3. What's going to trade out the x with? Y plus 5. So they literally just trade places. So trading the x for the y. They're going to swap places just like those ordered pairs did. And then we just need to isolate the new y. So it turns out to be a pretty easy process to do algebraically. All right, so I want to isolate this new y. So what should I get rid of first? What should we do? Subtract 5. Yes, I wasn't sure if I heard you right. Okay, subtract the 5. That's going to give me x minus 5 equals negative 2/3 y. Now again, how do I get the y by itself? What do I need to get rid of? The negative 2/3. How can I get rid of that? Well, this is negative 2/3 times y. Inverse operation is correct. So the inverse, in this case, is the reciprocal. We could divide by negative 2/3, but I really hate dividing by fractions. It's messy. So we're going to multiply by the reciprocal. Write that down so I can point to it when you ask me how to do that. I'm going to multiply both sides by, what's the reciprocal? Negative 3/2. So we're going to multiply the whole left side and the whole right side by negative 3/2. I really wrote that wrong. The better way to write it is the whole right side by negative 3/2 and the whole left side by negative 3/2. And when you do that, we would get positive 6/6, which is just 1. So we get y by itself. This is an okay answer on the left-hand side, but there is one thing that I can do, which is distribute in that negative 3. So that would give me negative 3x, and negative 3 times negative 5 is positive 15. And then it's all divided by 2. 2 is in the denominator. It's going to be under all the things. So this is a good way to write that answer. And then the only real thing that I might just be a little picky about is function notation. We started with f of x. And so whatever you start with, you should end with as well. So we're going to trade out this y and replace it with the function notation for inverse. So we're just going to trade it in for f inverse of x. Because that's the general rule of thumb in math. If you start with decimals, you can end with decimals. If you start with fractions, you can end with fractions. If you start with function notation, you should end with function notation. like consistency. I read a paragraph because my son has the science project to do, which is really irritating. I hate projects. Which is funny because I assign them all the time. Okay, but my kids' projects are annoying, like science fair. So, but my son has an insect project, and I was reading a paragraph, and they wrote, the egg of the monarch butterfly stays an egg for 4 days, and they wrote FOUR. And then later in the same paragraph, they said the caterpillar or larvae stays in the larvae stage for 2 weeks, and they just used the numeral 2. That's a consistency problem. If you spelled out 4, then you should spell out 2. It's really irritating. Okay, sorry. Here. F of x really just means y, and our first step is to swap the x and y. So what should I write? X equals 2y minus 5, all divided by 7. This is a slightly different setup here. What do you think you want to do first? There's a lot of things we could do, but right now all of this is being divided by 7. Can I get rid of that? Can I multiply everything by 7? So I'm going to multiply the whole right side by 7 and the whole left side by 7. What happens if the divide by 7 and the times by 7? They cancel. They undo one another. So that on the left we get 7x equals, now we just have 2y minus 5. That's much prettier to look at. All right, we're trying to isolate the y, so what should we get rid of first? How do we get rid of it? Add 5. So we're going to add 5. So then we'd have 7x plus 5 equals 2y. And then how do we get y by itself? How do we get rid of the 2? Divide by 2. Yeah, divide everything by 2. The 2's cancel out. I get 7x plus 5 all divided by 2. And again, I'm just going to trade out the y for function inverse notation. So f inverse of x. So trading in notation. Okay, questions on those two? One more. This one's the hardest one. Last one. F of x equals 4 over 3x plus 7. So f of x is the same thing as y, and the first thing we want to do is swap our x's and y's. So what should I write? X equals 4 all divided by 3y plus 7. This is a big problem because all of this stuff is in the denominator. I really hate that. So I want to move it out. So I'm going to multiply the whole right side by 3y plus 7. And I'm going to multiply the whole left side by 3y plus 7. So that I can move it over here and cancel it out on the right-hand side. I need to get it out of the denominator. So I have a 4 on the right. What do you suppose I need to do on the left? Distribute. Very good. We are going to distribute this x because they are being multiplied together. So 3y times x I could write as 3xy. And then 7 times x is 7x. Our goal, again, is to isolate the y. So I'm trying to get this thing all by itself. What do you want to move away first? Do I want this 7x? No, we're going to move it. So we're going to subtract 7x. So then I have 3xy equals 4 minus 7x. You could also write negative 7x plus 4 if you wanted to, same thing. Now again, we want the y. What do we need to get rid of? The x and the 3. So how do we get rid of those? They're all connected by multiplication. How do we break that? Divide it, yeah. So we can actually divide both sides. We want to get rid of them, so divide them away. So we're going to divide by 3 and divide by the x all at the same time, which makes it really handy. So we get y by itself, and then we have this on the right, 4 minus 7x, all divided by 3x. And again, I'm just going to trade the y for f inverse of x. Notation. This whole unit was just about notation. And rational exponents. Do you guys have questions for me? All right, you guys have class practice 18.